Okay, for number 10, we're given a graph. This is a graph of y equals f of x, and we have to answer all these questions just by looking at the graph. So we have to, all our answers are just using this portion only. There's no equation to plug anything into. Read it off the graph. The very first question asks you want you to find f of 5. And what this is saying is they want you to find the y value when x is equal to 5. Now this graph, everything is all labeled for the points. The one on the test may not, but there'd be a grid there so you could read your answer off the graph directly. These are all labeled so it's a little bit easier. So f of 5 means we're going to find the y value when x is 5. And we see that's negative 2 there, so we can just answer f of 5 equals negative 2. The second one, it asks us find all x such that f of x equals negative 3. Now this is actually asking you for the reverse. It's giving you the y value negative 3, and it's asking you what x value will give you a y value of negative 3. So when we look at this, we actually see that there's two places where you have a y value of negative 3. So we're going to list both those x values. We say x is equal to negative 5 and x is equal to 3. Now we have domain and range. Domain is talking about the x values that the graph is using. Your range is the y values the graph is using. So for domain, if you're talking about x values, the smallest x value that's being used is negative 5. The largest x value being used is 5. So since both of these are closed circles, we're going to use brackets and we'll write our answer as negative 5 to 5. Remember that if you have an open circle on one of those, then you're going to have a parenthesis on it. That number would not be included if it's an open circle. So domain is talking about only x values the graph uses. Now let's do range. Range is the y values the graph is using. You start with the lowest y value to the highest y value that's being used. The smallest y value that's being used here is negative 3. The highest one is 3, which means that your range is going to be between negative 3 and 3. The graph is solid there. There's no open circle, which means it will in fact use that value of 3, so that's why we are including both of those. We have the brackets on both. Okay, so next we have to find the decreasing and increasing intervals. So decreasing is as you move from left to right, you're looking for a part of the graph that's going downhill. So as you move from left to right, the section of the graph that's going downhill is this region right in here. Now I also put increasing even though it wasn't on the sample. I want us to make sure we know how to do both of those. So decreasing, you're looking for where the graph goes downhill as you move from left to right. So as you move from left to right, it's this region right in here. That's between the x value of 1 and 3. So I'm going to put 1 to 3, and typically we're going to use parentheses on our increasing and decreasing intervals because the endpoints were right here at this peak, for instance, and then also down here, technically it's not increasing or decreasing at that point. So that's why we don't include the endpoints there, we just use parentheses. For increasing, as you move from left to right, you're looking for a part of the graph that's going uphill. That's this piece right here. There's another piece here where it's going uphill. Remember, when you give decreasing, increasing intervals, you're only giving your answer in terms of x. So you're listing them as x values. This here, just to clarify, this is not a coordinate. I'm not putting down the 0.13. This is the interval from the x value of 1 to the x value of 3 is how I'm getting this. It's not a coordinate. So for increasing, between the x value of negative 5 and between the x value of 1, so between those two, between negative 5 and positive 1, that's where the graph is increasing or going uphill as you move from left to right. Now there's another section, this section right here, that's between the x value of 3 and 5 is another place where we have the graph going uphill as you move from left to right. Again, we're only indicating x values where it's occurring. You're not listing any y values, you're not listing any coordinates. These are all intervals, and that's how you're writing your answer. Now, part F, it says list the number at which. If you see that phrase, list the number is referring to an x value. Whereas this one, when it just asks you for the local or relative min, this is referring to a y value. So this one is x, this one is y, what they're asking you for. This is saying, what is the x value at which the graph has a local max? Now remember, local max, you have to have an increasing and a decreasing part accurate. This endpoint right here is not considered a relative max because you do not have a decreasing part that comes afterwards. So in this class, on a test, the way you want to interpret this is where we have an increasing and a decreasing, so at the top of a hill, that's the relative max. Just so happens that it's the highest point in the entire graph, but that may not necessarily be the case. It's got the word local, so local or relative, both of those are used. You're just looking locally or in that area, which is the highest. So in this case, what you'll just answer, your answer is 1 there. So the x value at which there's a local max that occurs at the x value of 1. Now this is asking for the local min. Local min means you're asking for the y value where the min is. So again, we're going down and we're going up. This is the point that we're referring to here. The y value there is going to be -3. Okay, so this is x value where you see list number at which. If it just says find the value of the local max or relative max or min, then you're indicating the y value only. The last one, how many times does a line y equal -5/2 intersect f? Y equals -5/2 is the same thing as y equals -2.5. This is a horizontal line going through -2.5. So if I put that in, -2.5 is about right here. So I'm going to draw in a dotted line all the way through, and that dotted line there, it intersects it 1, 2, 3 different times, which means I'm just going to put 3 down for the answer. There's no special notation for that. We just simply list 3. So you want to make sure you know how to do all these different types. Okay, so of course it could also ask list number at which there's a local min or indicate the value of local max. Those are some other variations. So these are all the different types of questions that will be asked in this one. Every single problem that you see here, all these questions asking you to refer to the graph, and so on the test there will be a graph given to you.